comes with the PyCrypto library, so it's fine. So we'll create our file. So I'm going to call it encrypt.py. Okay. Now, we're going to need to import some things. So, because we're going to be encrypting files, we need to be able to access the operating system. So import OS, so we can get like the file length. And let's also import random, because we're going to get random, a random IV, so we're going to need random at some point. Okay, now we're going to grab our encryption algorithms. So from crypto and .cipher, so we're going to grab a cipher. We're going to import AES, and that's all in capitals. And we're also going to grab the SHA-256 hashing algorithm. So from crypto.hash import SHA-256. Okay, now let's define our encrypt function. So we'll just call it encrypt. So encrypt. And it'll take a key and a file name to encrypt. Okay. Now we're going to need some variables. So we're going to need a chunk size. So this is going to be the chunks that we pull out of the file. So chunk size. And we'll make that equal to 64 times 1024. Save us from typing out the amount of bytes ourselves. Okay. Now let's create our output file. So our output file. And we'll just make it equal to what the current file name is, but we'll put a encrypted at front. So in brackets, I'll just put encrypted. And I'll close the brackets off. And I'll add that onto the file name that we've already got. And you can do whatever you want here. You could even just get input from the user of what they want the new file to be called. Or you could even overwrite the old file. Okay, file size. So we need the file size of the current file that we're going to be encrypting. And I like to turn this into a string and fill it to 16 bytes. But if you want to use something like a structure for getting the size of the file, you can go and do it that way if you like. So I'm going to turn it into a string, os.path, and we're going to get size of the file name. And then I'm going to z-fill this to 16 bytes. And then I'll just fill the left-hand side of the string with zeros. Okay, and we need one more variable, which is going to be the IV. And I'm just going to set that to nothing at the moment. Now let's generate our random IV. So for I in range and 16, because we want a 16-byte IV, we're going to get our IV and plus equals onto the end of it, the char of random dot rand int. So we're going to get a random int between 0 and 0xff. Okay. So that'll generate our random IV of 16 characters. Now we're going to create our encryptor object. So encryptor, and that's going to equal an AES.new, and that'll take the key that we pass into the function, and it's going to pick our mode, our cipher block mode, so that AES.mode underscore, and I'm going to use CBC, which is chained cipher block, and we're going to put in the IV for our AES. Okay, so that'll create our encryptor. Now we're going to open our files. So I'm going to use the with keyword, so with open, and we're going to open the file name, so the file we want to encrypt. I'm going to open it in read binary, and we'll call that as in file. Okay. Now, with this file, we're going to open up our output file to dump everything into. So with open, and our open's going to take our output file, and that's going to be in write binary as out file. Okay. Now, with our out file, so out file dot write, we're going to output the file size of the original file, and we're also going to output, so out file dot write, the IV, so that we can use it when we decrypt. Okay, now that we've output our file size and our IV, we can start encrypting all the data in the original file and storing it in our output file. So while true, so we're going to just keep going until we break out of this. We're going to create a chunk which equals infile dot read. I'm going to read our chunk size that we specified earlier. So chunk size. Okay. Now we're going to write an if. So if the length of chunk is equal to 0, so it's got nothing in it, then we're going to break out of our while. Else if the length of chunk modulus 16, so we can get the remainder, does not equal 0, then we're going to add some padding. So we're going to pad the chunk. So chunk plus equals, and we're just going to pad it with spaces. So space times, and open bracket, 16 minus the length of chunk modulus 16. So the length, 16 minus the remainder of the length. So that'll get how much more we need to pad with, and we're timing that by, well, we're timesing space by that. And that'll pad our chunk so that we can encrypt it. And now after we've done our ifs, we're going to use the out file, and we're going to write the output of the encryptor dot encrypt of the chunk. And that'll write out our encrypted chunk. And that's all we need to do for our encrypt function. Okay, now let's define our decrypt function. So def, I'll call it decrypt, and that'll take the key again and the file name. Okay, now we'll specify our chunk size again. So chunk size is equal to 64 times 1024. Okay, and our output file, we'll make that equal to the file name that we're decrypting, and we'll only grab everything after the first 11 characters, because after the 11 characters is the original file name, if you copy what I'm doing, because I added the encrypted in brackets of the original. So I'm just going to get rid of that encrypted in brackets. Okay, now with open, and I'm going to open up the file name. So I'm going to open up the file, in read binary as infile. And now we're going to specify our file size and our IV. So our file size is going to be equal to long of infile.read 16 bytes. And we're going to get our IV, which is going to equal the infile.read the next 16 bytes. Okay, so now we've read out our file size and our IV. We can create our decryptor now. So decryptor is equal to AES.new, and that'll take the key, and then our mode again, so AES.mode underscore CBC. And we can pass in our IV. Okay. Now, we're going to use the with command again, and we're going to open up our output file. So open output file, and that's going to be in write binary as out file. Okay. Now that we've opened up our out file, we're going to do while true, and we're going to grab a chunk. So chunk equals infile.read of chunk size, and then after we've read in our chunk size, we are going to do an if statement. So if the length of chunk is equal to 0, then we're going to break. And then we can decrypt the chunk that we pulled out of the file. So out file dot write the decryptor dot decrypt the chunk, and we're going to write the result out. Now, after we get out of our while, we're going to truncate the out file. So out file dot truncate, and what this is going to do is just reduce it to whatever size we specify, which will do the original file size. So this will truncate all of the padding that we added at the end of our encryption process. And that's our decrypt function done. Now we'll just write a small utility function called getKey. So getKey, and that'll take a password, and we'll create a hasher. So hasher equals SHA-256.new, and then we're going to give it the password, and then we're going to return the hasher.digest. So that'll return the hash of the password that we pass in. And now let's create our main function. So def main, and we'll just make a little menu. So create a variable called choice, and that can equal raw underscore input, and we'll ask the user, would you like to, in brackets, so E, capital E, encrypt, or in brackets, decrypt, question mark. Okay. Now we'll just write a simple if.